Hey guys, it's Mrs. Opal and
Annika.
Anders.
today we're going to learn about
Tree.
Diagrams.
All right, guys. All right, so we have example 17 here. Let's get started. Media usage and good grades. In January 2010, the Kaiser Family Foundation released a study about the influence of media in the lives of young people aged 8 to 18. In the study, 17% of the youth were classified as light media users, 62% were classified as moderate, and 21% were classified as heavy media users. Of the light users who responded, 74% described their grades as good, while only 68% of the moderate users and 52% of the heavy users described their grades as good. According to the study, what percent of young people ages 8 through 18 described their grades as good? Holy smokes, there's a lot going on here. When there's a lot going on here, I'm always going to suggest a tree diagram, okay? So let's get started. What's the first thing we know about this whole thing? We start with people. Okay, so if you're doing this with me on a notebook, give yourself some space, just like I did here. We have people ages 8 to 18. Okay, now the next thing is you need to kind of think about what comes first. Is it their media use and their grades, or is it their grades and their media use? If you can't tell, oftentimes you can just do it by what comes first in the problem. So in this problem, okay, we're gonna go with media users. How do I know? Okay, well, the grades are based off of their media, they're related or they correspond to what has already happened, something conditional, okay? 70% of the light users, so that's a condition there, so their grades are good, A's and B's. So 68% of the moderate. So that's why I know that, hey, I'm gonna start with the media usage, okay? So of the media usage, let's see, we have 3 of them, right? 17% of them were light media users, okay? So I'm gonna put LM for light media users, and that's 0.17. The next thing I'm gonna do, I'm gonna cross that off because there's just so many numbers. It's a nice way to stay organized. So 17% of the youth were light media users. I got that down. 62% were classified as moderate media users. Okay, so I'm gonna put MM here, and that is 0.62. Again, I'm gonna cross this off. And then finally, we have 21% were classified as heavy media users. So HM, and that was 21%. Okay, so this first branches of our tree is talking about media use. And again, how did I know to do media use first? Well, the grades are conditional. The percentages are based on being good are based on how much media they use. So that's how I knew that I had to do this first. Next, let's keep reading, okay? Well, let me rewind a second. If I add up this 0.17, 0.62, and 0.21, that should add up to 1, or if I have it as a percentage, it'd be a 100%. I would never suggest putting the actual percentage here. It's just a good idea when you're dealing with percentages to always move the decimal back 2 to the left, divide by 100, because when we're using our calculator, we want it as a decimal, as a proportion, okay? All right, next, of the light users who responded, 74% described their grades as good. So of the light media users here, 70% said their grades were good. I'm just going to put a G for good, and that's 0.74. Again, that 74% was based on a condition, the condition of that something's already happened, that they were light media users. Now, if I can be a light media user and not have good grades, so I'm going to put G complement because that means not. Well, it doesn't tell us, okay? It doesn't tell us what that is. But what you need to know is anytime you have a branch, that has to add up to 1 or 100%, like I said. So 1 minus 0.74, that's going to be 0.26. That's how I got that right here. Okay, so now we are on, right? We are on the, how do we define it? Moderate media users, okay? I'm gonna change my color here. 68% of the moderate users, so they have to be moderate users, 68% of them said they had good grades. So put G for good, 0.68, which means we also, of those moderate users, right? Moderate media users, some of them had bad grades. G complement, which means not, okay? So 0.1 minus 0.68, that is going to give us 0.32. I've used this 68%, and now let's go on to here. 52% of the heavy users describe their grades as good. Okay, so here's our heavy users. 0.52. So heavy media users can have good grades or they can not have good grades. Complement, right? And that's going to be 0.48. Okay. Again, these branches here have to add up to 1. Okay. The biggest piece of advice now that I can give you guys is to multiply across before you even answer the question. I've been teaching way too long where people now just stop and then they try to answer the question based off this tree diagram. They make this beautiful tree diagram and then they get the question wrong, right? Because they don't actually go across and describe what this all means, okay? So right here, what we have, ladies and gentlemen, is we have our sample space. There are 1, 2, 3, 4, 5, 6, 7, 8 different things that could happen. You can imagine if I had all these people in a hat and I pulled one name out, it would be one of these different options, okay? Well, what are these options? If I follow this branch right here, okay, this branch right here, if I start here, I have a light media user and good grades. That's going to tell me the probability of a light media user and good grades. So intersecting with good grades, that's going to equal what? Well, how do I know what that's going to equal? This is a sequence of events, light media user and good grades. I'm going to multiply that together, 0.17 times 0.74. That's going to give me 0.1258. So 0.17 times 0.74 equals 0.1258. And I'm going to quickly just go like this. Okay, let's keep going. If I follow this, again, this is the sample space and we're going to figure out the probability of our sample space right now. That's what I want to do. Again, a smart move is to take the extra minute to do this before you even answer the question. Okay, the next one is a light media user and doesn't get good grades. Okay, so that is, oh, we don't want that big one there. The probability of a light media user and good grades complements. So I'm just going to put GC like that if that's okay with you, so I don't waste my time trying to put it as a little exponent. If I'm a light media user and good grade and not good grades, excuse me, the probability of that happening is 0.17 times 0.26. And that's equal to 0.0442. Now what I want you guys to do is I want you to pause the video. I'm going to pause the video as well. And I want you to figure out the probability of the sample space of everything that can happen. So I want you to find the probability of being a medium user and getting good grades, a medium user and not getting good grades, just like we did here. So we follow it. I'm going to do that now. So when you press play again, you're going to see this all filled out and hopefully you have yours all filled out as well. Okay, guys, so you can see in parentheses here, I have my sample space, everything that could happen. And what I did is I found the probability of each event here in the sample space. And just again, keep in mind, how did I do that? I went through and I just followed the tree diagram. I have a kid, 8 to 18, light media user, not good grades, multiply, and we get our answer. Medium, good grades, 0.62 times 0.68. Medium, not good grades, 0.62 times 0.32. Heavy, good grades, 0.21 times 0.52. Heavy, not good grades, 0.21 times 0.48. Now here are all the different probabilities. If I would add all of this up, it should equal 1, okay? Now, next thing, I know some of you are gonna be like, wow, that's a lot of work, but I promise that little bit of extra work is going to pay off when it's time to answer the questions, because oftentimes there are multiple questions or multiple parts to these tree diagram type questions, and then you have everything that you need. Now, the last thing I want to advise you, once you fill this out, I want you to circle these numbers. These are the only numbers we care about now. We no longer care about the numbers in the tree diagram. You will not use these to answer any of the questions. You will only use these numbers. To what extent, we don't know right now, but we do know we're only going to use those. The only reason I'm erasing it right now is because I covered up the question. Let's go ahead and answer the actual question now, okay? According to this study, what percent of young people ages 8 through 18 describe their grades as good? Okay, describe their grades as good. I'm going to use my highlighter here. Right here, we have a light user who described their grades as good. We have a medium user who described their grades as good. And we have a heavy user who described their grades as good. We could be a light, media, and good grades, or a medium user and good grades, or a heavy user and good grades. So what am I going to do, you guys? I'm going to add those three numbers up. 0.1258 plus 0.4216 plus 0.1092. And that gives me 0.6566. And that's my final answer right there, guys. Oops, I don't know why the decimal didn't go with it. Let's redo it there. All right, ladies and gentlemen, we're going to do one more together. I know we're at the 12-minute mark, but I really do think it would be helpful for you to do one more with me. I've seen a lot like this before on free response questions. I just think it's a really important question, and this is an important skill, okay? So I think it'd be important to practice one more time. Also, the benefit of doing the next one is it's a conditional probability one, and I have seen them on tests before that we have given, and I want to know that I want you to know that it is fair play on a test that we could give you, okay? Let's get cruising. Suppose there's an outbreak of a rare disease in the United States. It is estimated that 1 in every 1,000 people will contract the disease. A diagnostic test is available that is 97% accurate. That means it returns a positive results for people who do have the disease, and 95% accurate returns a negative result for people who do not have the disease. Given that a person has tested positive for the disease, what is the probability the person actually has the disease? Again, a lot going on here. When there's a lot going on, do a tree diagram. So what do we have? We have people in the United States. That's where we're going to start. Okay, what comes first, the test or actually having the disease? Well, this right here, this accuracy is based on a given condition of either having the disease or not. So that is conditional. So that's going to go second, okay, right? Like this is going to go second as well. 95% accurate. That's based off of a condition of having the disease or not. So we're going to start with this 1 in 1,000 people. Okay, with that then, we have these people in the United States that either have the rare disease or they don't. So rare complement. The chances of them having this rare disease, it's estimated that 1 in 1,000 people have it. 1 divided by 1,000 is 0.001. It doesn't tell us the percentage of people that don't have it, but we know that these have to add up to 1. Okay, so 1 minus 0.001, well, that gives me 0.999. Okay. Next, we're going to get tested. A diagnostic test is available that's 97% accurate for people who do have the disease. Okay. I'm going to do something. I think it's going to make it look a little bit better because we keep talking about the disease. I put rare. Let's put D instead. Sorry, guys. Okay, so we said it's 97% accurate for people who do have the disease. That means it's going to return a positive result, plus 0.97. Well, if it doesn't return a positive result, that means it's got to return a negative result. That's 0.03. Okay. Well, if it's 97% accurate for people with the disease, there's a 3% chance that it's inaccurate for people who have the disease. This is called a false negative here. Okay. A false negative. All right. For people who don't have the disease, it's 95% accurate. Be careful when you read this. Sometimes it does not give you this helpful hint of returning a negative result, and then people go ahead and put positive there. If this test is accurate, this person doesn't have the disease, and so it's going to have a negative result, and there's a 95% chance of that. Which means there's a 5% chance of a false positive. Next up, what we want to do is we want to find the sample space and the probability of each event. Okay, so this first thing that could happen is the person could have the disease and test positive. We want to figure out the probability of this happening. We're going to use the multiplication rule, 0.001 times 0.97. 0.001 times 0.97. That gives me 0.00097. Okay. The next thing that could happen, so